Imagine standing on the ocean floor with millions of tons of water directly above you. Now imagine building a road through it. It sounds almost impossible, but engineers have been building tunnels beneath rivers, seas, and entire bodies of water for decades. So how do they actually do it? It all starts on the ocean floor. Before digging begins, engineers need to know exactly what lies beneath the seabed. They study the soil, rock, groundwater, and pressure to find the safest possible path for the tunnel. Specialized survey ships use sonar, drilling equipment, and other technology to map the ground beneath the water. Because when you're building a tunnel this deep, even a small mistake can have enormous consequences. Once engineers understand the geology, the real construction begins. And one of the most impressive machines in the process is the tunnel boring machine, better known as a TBM. These machines can be hundreds of feet long and weigh thousands of tons. At the front is a massive rotating cutter head, covered with powerful cutting tools designed to break through rock and soil. As the cutter head rotates, it slowly eats its way through the ground. But digging beneath the ocean creates one enormous problem: water pressure. The deeper the tunnel goes, the greater the pressure becomes. If water suddenly breaks into an excavation, the tunnel could flood extremely quickly. That's why the TBM is designed to carefully control the pressure at the cutting face. As it cuts through the ground, the machine continuously removes the excavated soil and rock. The material is transported through the machine and carried away toward the surface. But the TBM doesn't just dig the tunnel. It also helps build the tunnel behind itself. Large precast concrete segments are placed together to form a strong circular lining. These segments fit together like pieces of a giant puzzle. Special seals between the segments help prevent groundwater from entering the finished tunnel. Then the machine moves forward, and the entire process starts again. Cut, remove, build, move forward, and repeat. Meter by meter, the tunnel slowly grows beneath the sea. In some projects, the tunnel can be buried dozens of meters below the seabed, protected by thick layers of soil and rock. But digging the tunnel is only half the challenge. Engineers also have to make it safe for thousands of people to use. Powerful ventilation systems keep fresh air moving through the tunnel. Fire detection, emergency lighting, drainage, communication systems, and emergency exits all have to work together. Every system has to be carefully tested before the tunnel can open. And then comes one of the most important moments in the entire project: the breakthrough. After years of excavation, the tunnel being constructed from one direction finally meets the section coming from the other side. The alignment has to be incredibly precise. When the final connection is completed, two separate underground passages become one continuous route. What was once solid rock beneath the ocean has now become a road or railway connecting places that were separated by water. From the surface, you might never even know it's there. The ocean can look completely normal above it. Ships continue to travel across the surface. Waves continue to move. But dozens of meters below, a massive engineered structure is carrying people safely through the earth. And that's what makes underwater tunnels so incredible. The most important part of the journey is happening where almost nobody can see it. Behind the walls is an enormous combination of engineering, machinery, concrete, steel, drainage, ventilation, and precise calculations, all working together against pressure, groundwater, and the weight of the ocean above. So the next time you travel through a tunnel beneath the water, remember this: you're not simply driving through a hole in the ground. You're traveling through one of the most impressive engineering achievements humans have ever built.